we're going to work on the practice problems related to Module 8. These problems can be found in practice problem folders of Module 8 folders, and we're going to go over the first problem. Problem 1. In this problem, we are looking at the life of a light bulb in hours, and so that's our random variable. So our random variable is a measure, and this random variable is known to have normal distribution with a standard deviation of 25 hours, and obviously we don't know the average of the life of the light bulbs. We take a sample of size 21. What is the notation for showing the sample size?
Little n.
N. 21. We take a sample of size 21 bulbs, and the average of this sample in terms of the life of the light bulbs is 1014 hours. So X bar is the notation that we use for the average of the sample, 1014 hours. And in part A, we want to construct a 95% two-sided confidence interval for the mean life, for the average life of a light bulb. So 95% two-sided confidence interval. So what is, okay, so I want to construct a confidence interval. When we want to construct a confidence interval, we know the formulas, right? If sigma or standard deviation of the population is known, then we are going to use one of these formulas. So if it's a two-sided confidence interval, it's going to be X bar minus Z of alpha over 2 sigma over square root of n, X bar plus Z of alpha over 2 sigma over square root of n. That's a two-sided confidence interval. If it is one-sided, it's going to be X bar minus Z alpha sigma over square root of n. Or if we need an upper bound, it's going to be X bar plus Z alpha sigma over square root of n. Okay, so the first one is a two-sided, and the second one, but the second one and the third one are the one-sided confidence intervals. And this is when the standard deviation of the population or variance of the population is known. If the sigma is not known, what is the change that we make in this formulation? If the standard deviation of population or sigma is not known. What do I use instead of sigma if I don't have a standard deviation of the population?
The sample standard deviation.
Yes, we use sample standard deviation. And what is the notation for that?
Little s.
S. Okay. So if sigma, which is the standard deviation of the population, as if I had access to all the light bulbs in the world, right? All the light bulbs that actually have the same brand and same type that I'm looking at. If I had access to all the light bulbs in the world, then I could say that I know the standard deviation of the population. That would be sigma. But if that's not the case, I don't know the standard deviation of the population. So the best I can do is to take a sample and look at the standard deviation of the sample, which I'm going to show with the notation lower s. So that would be the standard deviation of the sample. And in that scenario, the formula for the confidence interval, everything I wrote is going to change, and it's going to be X bar minus T. Let me just make sure S over, oops, God. Sorry guys. S over square root of n. Upper bound is going to be x bar plus t. And then if I want a lower bound one-sided, it's going to be x bar minus t. And if I want a one-sided upper bound, it's going to be x bar plus t. Okay, so these are basically the formula for constructing confidence interval: a two-sided or a one-sided lower bound or upper bound. And the only thing that you guys have to pay careful attention to is that if the standard deviation of the population is known, or if the standard deviation of the population is not known. In that scenario, we replace sigma with S and we replace Z with T. But the structure of the formulation is the same. Now, for this problem that is given to you here, do you have the standard deviation of the population?
Yes.
Yes, we do. It's given to you here. It says sigma is like this. If that's not the case, the problem doesn't tell you anything about the sigma. Then you have to calculate S, and then you have to use the second type of formula. So I have the standard deviation of the population, then I have to use this first set of the formula. And here in the problem, it says construct a 95% two-sided confidence interval. So I have to pick this formula. That's the one I need to be able to construct the confidence interval. And in this formula, I need X bar, which is the average of the sample. I have it here. I need to know sigma, which is a standard deviation of the population. I have that too. I need to know n, which is the sample size. I have that too. The only other thing that I want is the z of alpha over 2. And for that, the only thing I need to know is alpha. And the question tells me 95% two-sided confidence interval. How can I get alpha out of that?
1 minus the confidence interval is equal to alpha.
Exactly. So alpha is 1 minus 0.95 significance level, and that's going to be 0.05. And in the formula, I need z of alpha over 2. So then alpha over 2 is 0.025. So I need to find z of alpha over 2. So if I go to the z table, I have to find the value of z where the area on the left side is 0.025. Here. Or here. So that's minus 1.96, right? However, when we are looking at z, we always consider the positive number. So then z of alpha over 2 is 1.96. Then we are good to just put these numbers in the formula and find the confidence interval. So formula one more time, x bar minus z alpha over 2 sigma over square root of n. And x bar 1014 minus 1.96 sigma 25, right? Square root of n 21. And it's going to be okay, so that's going to be a 95% confidence interval for average of the life of these light bulbs in this process. So that means with 95% chance, this interval will contain that unknown average. That's mu. That's the average that we don't know, average of the whole population. I don't know that. But with 95% chance, this interval will contain that unknown average. Then in part B, wants us to find a 95%. Is there any question, guys, before I go to part B? Okay. In part B, we want to construct a 95% lower confidence bound on the mean. Okay, so part B, we want a lower confidence bound. So for the lower bound, the formula is x bar minus z of alpha sigma over square root of n, the standard equal to mu. So here I have basically everything, 10, 14. The only thing I need here, sigma I know is 25, the square root of n is 21. I need to know z of alpha, and that's z of alpha is 0.05, right? I need to calculate that. If I go to the table, 0.05,
1.64.
yeah, 1.65, and always pick the positive number. So okay, so that would be the lower bound for our confidence interval. If we need upper bound, we just use the right formula for that one. So basically for calculating confidence intervals, the only thing that you guys need first, make sure you will have a cheat sheet for the exam, right? Make sure to write down the correct formula for confidence interval. So the formula is going to be one of this group or one of this group. Make sure to read the problem and understand if the standard deviation of the population, sigma, is given to you or not. If it is given to you, use the one of the formulas in the first set. If it is not given to you, use one of the formulas in the second set. If you use one of the formulas in the second set, then make sure to use the T and to use the S, standard deviation of the sample, instead of a standard deviation of the population. Other than that, there is nothing tricky about constructing confidence interval. Okay. Okay, so problem 2, I want you guys to help me to solve this. Given what we already went through, I want you guys to help me to solve number 2. If you have any question, or if I'm fast, please let me know so I can slow down. Okay, question 2. The number of steps to cover the same distance was measured for 41 randomly chosen people. The sample mean is 2220 steps, and the sample standard deviation is S equals to 444 steps. Assume distribution to be normal. Okay, so, and then we want a 90% two-sided and one-sided confidence interval. First of all, tell me from the problem statement, what are the things that are given to you? From the very first line, the number of steps to cover the same distance was measured.
N is 41.
For 41 randomly chosen people. So what is 41? That's sample size, 41. What is given in the second? The sample mean is 2220 steps.
It will be S bar and just the standard deviation S, 444.
And then they also give us S.
S.
Standard deviation is 444.
Yeah, exactly. It's the standard deviation, but it's important for you guys to make sure to read the problem carefully. It's the standard deviation of the sample, and that's S. assume the distribution of this random variable, and our random variable is number of steps to cover the same distance. This random variable has normal distribution. Now we need to construct a 90% two-sided confidence interval. And for that, the formula was okay. So I have x bar, I have s, I have n. The only thing I need to find out here is t of alpha over 2 and n minus 1. Alpha obviously here is 1 minus 0.9, which is 0.1. So alpha over 2 is 0.05 and n is 40. So with these two, I have to find out the value for t of alpha over 2 n minus 1. I don't have the t table in my tablet, but I want all of you guys to please open the t table. If you guys want, I can switch to my computer and go over the t table with you guys. But I want you guys to open the t table and tell me what is the value that you find for t. Mika, don't answer this question, please. Tell me what is the value that you want find for t. So t of 0.05 and n minus 1. Sorry, that's not n. That's n minus 1, 40. Yesenia, don't answer that. Mika, don't answer that. Can you guys please take a look at the t table and tell me what is the value that you find for this? Because basically that's the only thing you need to find out. Everything else is given to you in the problem statement. That's the only thing you need to find on your own and use the right formula and you will be correct 100%. So let's go to the t table.
I put 1.68.
0.704.
1.6.
No, 2.704.
Why 2? You're looking at 0.05 for alpha and n.
Sorry. I looked at 0.005 instead.
No worries. Go back and look at 0.05.
Yeah, 1.684.
Exactly. 1.684. So that's the value of the t. Okay. If you guys feel comfortable to find the value of the t, that's the only thing that you need, because as you can see here, n is given to you, xy is given to you, s is given to you. You write the formula in your cheat sheet. You as long as you find the right t value from the table, you get the problem right. Okay, so for this, okay, for this then it's going to be 2220 minus 1.684 s square root of 41 and when we do the calculation, this is going to be 2103. Okay. So with 90% confidence, this interval will contain the unknown average of this random variable. So that's part A. In part B, we want to find a 90% lower confidence bound. So the formula for lower confidence bound is going to be x bar minus t of alpha s over square root of n less than or equal to mu. 2 to 20. S, we know, 444, square root of n, 41. So the only thing I need to find out is t of, as the t value. So t of alpha, 0.1, n minus 1 is still 40. Can you please tell me what is this t value from the table?
$1.303.
Exactly. Everyone else could see that? 1.303. We know the alpha. We know the degree of freedom from the table. And then all we need to do is to find this t value. And if we do that, then it's going to be 213 is equal to mu. If you want to calculate an upper bound for the confidence interval, is the same. It's just the formula. Sorry. Okay, so those are the scenarios when we use the confidence when we calculate the confidence interval. If standard deviation of the population is not known, so but we have the standard deviation of the sample. So just make sure when you read the problem carefully, if you look at this problem that we had, if you read the problem carefully, it says that ensemble standard deviation is this much. So make sure as you write down the summary of the problem statement, that's sample standard deviation, that's S, that's not sigma. Once you find that out, then you just pick the right formula, and pretty much everything else should be given to you in the problem statement except the t or z value, and all you need to do to find those values from the table and put it in the correct formula, and you have the answer. Okay. Any question, guys?
Are those signs correct, Professor? As far as the greater than equal to and less than equal to for B and C? Because for B, you're creating a lower bound.
Yeah.
So.
Yes, less than.
Okay.
Yes. Thank you for catching.
Yeah.
Yeah. Yeah, we want to be, this is the lower bound one-sided, lower bound one-sided, upper bound one-sided. So if it's upper bound, we want our mu to be less than this. Just guys, make sure to please correct this sign. Was there any other question, guys? Okay. Let's go to problem 3. Okay, I want you guys to help me to solve this problem. During an independent research, 2,500 randomly selected people were interviewed whether they visit their dentist for a regular dental checkup or not. Actually, no, I'll do that because that's a new, it's not a new one, but we didn't do it in the previous two. But then we do another one together. During an independent research, 2,500 randomly selected people were interviewed whether they visit their dentist for a regular dentist checkup or not. Only 2,000 gave a positive answer. Calculate a 95% two-sided confidence interval on the proportion of people who regularly visit their dental doctor. So here, what we have is we want to construct a confidence interval for the proportion of a characteristic of interest in the population. And the formula is, so if you want to develop a two-sided confidence interval, it's going to be p hat. And if we want to construct a one-sided confidence interval for a lower bound, and for the upper bound, okay. So we have the same notation in the videos, right? Just to make sure. Okay, so what is given to us here?
N is equal to 2,500.
The sample is 2,500. That's what we see in the first line. During an independent research, 2,500 randomly selected people were interviewed. So that's the size of sample. And out of these 2,500, only 20,000 of them gave a positive answer to the question that if they see their dental checkup regularly or not.
So X bar equals 2,000. Or just X equals 2,000.
Exactly. So that help us, that information help us to calculate p hat.
P hat is X over N.
So that's 2,000 over 2,500. That's going to be 0.8. So which shows that in this sample of 2,500 that people that we interviewed, 80% of them visit their dental doctor regularly. Okay, so that's the p hat. Now, however, I don't know the value of this p or percentage of the population that visits their dental doctor, let's say in the US. I don't know the exact value of percentage of population that visit their dental doctor regularly. I don't know that. All I have been able to do is to take a sample of size 2,500 people, and I have interviewed them, and out of this sample, 2,000 of them said they meet their doctor regularly. That gives me a sense that about 80% of the population is meeting their doctor regularly, but I'm not sure about that. That's just the average, that's just the proportion of the sample. So I want to construct a 90% confidence interval for the proportion of the population that meets their doctor regularly. And I want to construct a two-sided confidence interval. So I have to use the first formula. That's the formula for a two-sided confidence interval. And let's do that. So here, as you can see in the formula, p hat is the main thing that we want, which we already have it here. The other thing that I want is z of alpha over 2. And alpha here is 5%, so alpha is 1 minus 0.95, which is 0.05. So alpha over 2 is 0.025. So z of 0.025 is 1.96, right? .025, yeah, here, that's the number that we just found. 1.9 minus 1.96, but we always need the positive value, so z of 0.025 is 1.96. Okay, so if I have z, and if I have the value of p hat, that's all I need to put in this formula and construct the two-sided confidence interval for proportion of the population that meets the dental doctor regularly. So then if I put the numbers in the formula, that's 0.8 p hat minus 1.96. Okay, so if we do the calculation, it's going to be okay. So with so this confidence interval will contain, with 95% confidence, this interval will contain the unknown proportion of the population in terms of proportion of people that will meet their doctors regularly. So this confidence interval contains that unknown proportion with 95% chance. Okay. Okay, so for the proportion as well, just make sure to read the question carefully. Make sure you know if it's a two-sided or if it's a one-sided confidence interval. Find the proportion in the sample that you have, p hat. Find the correct value of z from the table. Use the correct formula, and you are guaranteed to get the right answer. Okay. Question 4. Give me one. Okay. Well, help me with this one. Question 4. A new method had a success rate in removing kidney stones of 289 out of 350 patients. Construct a 95% lower confidence interval for the proportion of the patients with kidney stones successfully removed using this method. Design, okay, so we answer to the next one. Next question next. Okay. Construct a 95% confidence interval for proportion of patients whose kidney stone was successfully removed using this method. The other things that we know about this new method is that this new method has performed successfully in 289 patients out of 350 patients for which we have used this method. Mika, do not answer, please. Can someone tell me what is the information that is given to us in the first problem, in the first line? So first of all, what is, when we look at the proportion, obviously it says construct a 95% confidence interval for proportion. So this is proportion of what? P that we don't know is
289 over 350.
Okay, so the P that we are looking for is proportion of people who reacted successfully to the new method. Okay, we have a new method in the healthcare for removing kidney stone. We don't know the chance of success of this method. However, the only thing we could do was to take a sample, get a hold of 350 patients who have kidney stone, and implement this new method on these patients, and then see the results. And on the results that we get, we see that 289 of the patients reacted positively to this method. So I don't know who answered 289 over 350, but what is this value? What is the notation I have for this?
The sample proportion?
P hat, exactly. That's the sample proportion. 289 out of 350 patients have answered successfully or have reacted successfully to this new intervention. So that's going to be 0.826. And then it says calculate a 95% two-sided confidence interval. No, sorry. I was looking at a different question. It says construct a 95% lower confidence interval. So the formula is p hat minus okay, so this formula gives me a lower bound, a 95% lower confidence interval. So obviously I have p hat. The only other thing that I need here is z of alpha. And alpha is, since I need a 95% confidence interval or lower bound, it's going to be 1 minus 0.95, which is 0.05. And z of 0.05 is 164.
Yes.
So I think for some of these z's, you probably should already like know them by heart. Z of 0.05, z of 0.025, and things like that. Okay, so if I know the z and I know the p, then all I need is to replace those in the formula. Put 65. Okay, so then P, the proportion of population that responds positively to this new method with a chance of 95% falls in this interval greater than 0.79. Now, the other question that I have asked is that, does this confidence interval support the claim that at least 85% of procedures are successful? Give 30 seconds to it. Let's, before answering, please wait 30 seconds. Let's give time to everyone to think. Does this confidence interval support the claim that at least 85% of procedures that are performed on patient using this method are successful? Anyone wants to answer?
The consensus in the chat is yes.
Okay. I'm not looking at the chat, but yes, the answer is yes. Yeah, so we need, if we need to claim, or if
is the 95%.
Yeah, with the 95% confidence, if we need to claim that this new method is 85% successful, we can do that given the interval, given the one-sided interval that we have observed or we have obtained for P, we can definitely claim that this new method is 85% successful. So if we need to use that sentence in advertising or anything for this new method, that's a valid statement that we can say. This actually, the confidence interval and test of hypothesis are used largely in public health and healthcare. Basically, so what is the whole point of the statistics? Remember, the first part of our class was probability. When everything was given, we knew we are looking at normal distribution, exponential distribution, binomial distribution. They were given to us. But when we came to the module 7 and 8, then we looked at situations where those things were not clear. All we had was the data. We knew something is random. We knew the chance of success of this new treatment is random, but I don't know exactly what is that value. So all I can do is to take a sample and try this new intervention on the sample and then say something based on the sample. However, this is just one sample. If you take another sample of 350 or 500 or whatever number of people, the proportion of success that you may see is different. So then the question is that, what can I say then? If the proportion of success for any sample is different, what should I say? What is the chance of success, or what should I claim about this drug? That's why we construct all the confidence interval and all the test of hypothesis and methods like this to be able to say something statistically reliable about a random phenomenon. And that's why these things, as I said, are used heavily in healthcare and public health to be able to say something about the chance of success of the new methods or new drugs and things like that. And don't rely just one sample, but take one sample, but build something a lot more reliable, statistically a lot more reliable by confidence interval, by tests of hypothesis, and so forth. Yeah, so I have friends that are in medical field and they heavily use statistics, especially confidence interval and tests of hypothesis. Okay. Any question, guys, so far? Okay. Let's go to okay. Let's go to problem number 5. We have 5-year statistics of the average amount of wheat crop in terms of tons harvested from 1 kilo square meter per year, and the results are as follows. So these are the these 5 numbers that we have for 5 consecutive years. They have looked at the average amount of the wheat harvested, and these values are in tons. So we have 5 values. So basically, what is the question 5? So what is the sample size here?
5.
5, because we are looking at the amount of wheat that we can harvest from a specific land, right? We don't know every year the amount of harvest that we have is different. This may be affected by precipitation, temperature that year, the quality of the soil, and so forth. We know that every year the amount of wheat harvested from that land is different, it's random. But we want to get a sense of the average amount of harvest, let's say, that we are going to get from that land. What we have been able to do is to look at the average amount of, what we have been able to do is to look at the amount of harvest in 5 different years. And these 5 values is given to us. So basically we can look at this as our samples. So I have a sample of 5 different years. So the size of the sample is 5. We want to test the hypothesis that the average wheat crop is 550 tons per that amount of the land at significance level 0.05. And okay, so basically what we have here, can you tell me what is our null hypothesis?
You want me to?
Wait. So part A, wait, Mika. Part A, we want to test the hypothesis that the mean wheat crop is 550 tons. So in our null hypothesis, we want to check if the average of the wheat that we are going to get from that land each year is
Elizabeth says it's equal to 550.
Yeah, it's 550 tons. Mika, did you say something? I couldn't hear you. Can you repeat?
I was just reading the chat to you.
Oh yeah, okay. I think it's, guys, it's just a little challenging for me with my iPad and computer and everything. Let me, okay. Okay, yeah, Elizabeth, thank you. Okay, and then our null hypothesis, our alternative hypothesis is that the average is not this average. Okay, what else do we know here? What is the, and obviously alpha is given to us, 5%. What is the other important things we need to know about this type of problem before we start?
I think the standard deviation is not given. So
Okay, we need to know if the standard deviation of the population is known or not. If the standard deviation of the population is known, it should be given to us in the problem statement. But here, there is nowhere in the problem statement that we know anything about the standard deviation of the population. So that information is not given to us. So if I don't have a standard deviation of the population, then all I have to live with is a standard deviation of the sample. And if the standard deviation of the sample is given to us, okay, great, we are going to use it. If it's not given to us and we know the values in our sample, then we have to find it. And here, if we find the standard deviation of this sample of 5 numbers that you can see, the standard deviation is 27.68.
6.8.
Okay. Now,
wait, Professor, how did you get the sample? The sample the standard deviation?
what is the question?
Where did you get the value?
We have to calculate it. We did have we had it in module 6, if I'm not wrong. We have to calculate the standard deviation of the sample.
Oh, so we computed it.
Yeah, we have to compute it. We calculate it. It's not given to us. We have the sample. Sample has 5 elements.
Oh, I see.
Yeah. So those 5 elements, 560, 525, those are the average of the wheat crop every year. So you have a sample of size 5. Each those 5 samples are is given to you as well.
So we need the formula for previous modules for to find the standard deviation.
Exactly. So you need to find the standard deviation here. So that would be the standard deviation of the sample that we are going to find. And what else do I need here to be able to start the
calculate X bar?
I need to also know the average of this sample as well, which is not given to me here. It could be given to you, like in a lot of problems that we have, or a lot of examples that we have looked at so far. We say, we take a sample of size 20, average of sample is this, the standard deviation of sample is this. So it very well can be given to you guys. Here in this example, all that is given is the 5 values in each 5 samples. So we have to calculate average of this sample and standard deviation of the sample, which is the case in most of real world problems that you may look at. You are going to take a sample of the population, and look at the characteristic of interest, and you have to calculate the average of the sample and the standard deviation of the sample pretty much most of the times when you use these methods in the real world. So okay, so then the average of these samples, when we add all those 5 numbers, 560, 525, 496, 543, and 499, when we add them all and divide by 5,
24.6.
to be 524.6. So that's going to be average of the sample. We also have to obtain the standard deviation of the sample. The size of the sample obviously is 5, and what we need to do is to test this hypothesis. And to be able to test the hypothesis, the first thing I need to find out is to find the t-statistics. And here it's going to be X bar. And why do I put T and not Z for the test statistics?
Because our sample size is too small to use the central limit theorem.
There's one more important reason.
Professor, so
We're using sample deviation.
Exactly.
Yeah.
So the question I asked was that when I want to calculate the test statistics, why do I calculate T0 as opposed to Z0? And the answer that was given was that because we do not have the standard deviation of the population, we only have a standard deviation of the sample. And because of that, we are going to use the T distribution. So my test statistic has T distribution, so I have to calculate T0. Okay, so it's X bar minus mu naught divided by S over square root of N. X bar mu naught S over square root of N. And when we do the calculations, the result is minus 2.05. Okay. Now, can you tell me, okay, this is the value of my test statistics. Can you tell me what are the values I have to compare this one to and then decide on the rejection or fail on the rejection of the null hypothesis? How do I get the critical values? For a two-sided test, I have to look at T of
Alpha over 2 and N minus 1.
and N minus 1. And alpha over 2, given the fact that alpha is 5%, alpha over 2 is 0.025. And N minus 1 is 5 minus 1, which is 4. Okay, can everyone please go to the table and see if we can find the value of this T? Can someone tell me what is that value?
2.776.
Exactly. Okay. So then for a two-sided test, I have to check the value of the test statistics with this T value. So if the value of the T statistics is greater than 2.776, or if this value is less than minus 2.776, then what is the conclusion?
Reject the null hypothesis.
Exactly. So you compare the value of your test statistics with your critical value. And remember, if this is a T table, so these are these values. So this is minus 2.776. This is 2.776. And this is the area that in which we reject. So if the value of this T statistics is anything greater than this or anything less than this, then I'm in the rejection area. Okay, so then in this scenario, we reject the null hypothesis. And the value that I have is minus the value I have for the T statistic is minus 2.05. Is it in the rejection area? Is this value for my test statistic minus 2.05? Is
No.
number in the rejection area or in the fail to reject area?
Fail.
In the not rejection area.
Exactly. Exactly. So because the value of my test statistics is in the fail to reject area, it's not in the rejection area, then the conclusion of this test is that we are failed to reject the null hypothesis based on this sample. So we fail to reject that the average of the crops we can get from this land each year is about 550 tons. Okay, so that's that. Also, we want to construct a 95% confidence interval of the mean. Okay, you guys have to help me with that. Two-sided confidence interval, a 95% two-sided confidence interval. X bar minus and when we do all the simplification, this is the final value for the confidence interval, for two-sided confidence. Okay, now, so this is my two-sided confidence interval for this problem. What is going on? Okay, so this is a two-sided confidence interval I found for the average of the crops we can get from this land, and that's a 95%, right? Yeah, so that's a 95% confidence interval for the average of the crops we can get from this land. So the average of the crops we can get from this land in each year falls somewhere in this interval with 95% confidence. So now this is my question for you guys. Forget about everything we did in previous section. If this is the confidence interval that you have, so you have been able to calculate the confidence interval, and you still want to test the null hypothesis of mu equals to 555, that's the 550. 550 versus mu is not 550. And this confidence interval is all you have been able to construct. Can you tell me how would you conclude based on this confidence interval? Let's give 30 seconds to everyone to think, and then I ask you. You still want to test this null hypothesis and this confidence interval, which you constructed, given everything you know, is all you have for conclusion.
I would say yes, because the population mean, well, the hypothesized population mean is inside the confidence interval.
Okay. Anyone else has any other? Let me look at the chat this time. Okay. Everyone agrees with the conclusion? So we still fail to reject null hypothesis. Why? Because the hypothesized mean, the mu equals to 550 tons that we want to look at, falls in this interval that we have constructed, falls between 490 and 558. So, and as I said, this is the interval that contains the unknown mean of this random variable with 95% chance. So, given the fact that the hypothesized means is in this interval, in this confidence interval that we constructed, we say that we fail to reject H null just because the mu naught, the hypothesized mean, is in our confidence interval. So we failed to reject the fact that, we failed to reject the hypothesis that mu is not 550.
The same thing we
Yeah.
figured out in part A.
Can you repeat, Mika?
It's the same thing we figured out in part A.
Exactly, it's the same conclusion, so that's good. But in part A, we decided on the rejection or failed to rejection of the null hypothesis using the T statistics and comparing with the critical values and so forth. But here in this in part B, I wanted you guys to make the conclusion based on confidence interval. So this is all you have. We didn't construct any specific test statistic or anything. So similar to what I believe you guys had that in one of your quizzes as well. We can decide about the situation of a hypothesis using the test statistic method that we just did in part A. We can decide using the confidence interval method that we just tried. We can decide using the p-value method, I'll give you examples of related to that on Thursday. P-value, critical value methods. So all of those are different ways for us to make conclusion about the hypothesis test. Okay, so
Professor, I have a question.
go ahead.
How did you calculate S?
S?
Sorry, it was like at the beginning of the problem.
The sample standard deviation, the formula.
The 27.68, yeah. Thank you.
Sure. Here, basically, xi is any one of your samples. So here I have 5 samples. I have x1, x2, x3, x4, x5. So all those 5 values are shown by x1 all the way to x5. Then I look at the average of them, which is x4, which was the numbers that we already had. And then n-1 is just sample size. So basically this, remember, the standard deviation or variance is a measure of a spread around the mean. So that's why this is our mean. This is the mean of the sample x bar. What I calculate here, when I deduct any of these values of the sample minus x bar, I look at how each one of my sample values are far from the mean. That's why this part is calculating from me. And I raise it to the power of 2 because all that I care about is that how far they are from the mean. If I don't raise them to the power of 2, then the plus values and the minus values cancel each other. But I raise them to the power of 2 because all I care about is that how each one of the sample values is far from the mean, which I have in my x bar, and then I divide it by n-1, and that gives me a measure of spread around the mean. And that's the whole definition of variance or standard deviation. They are a measure of the spread around the mean of the sample.
Okay, thank you so much for the clarification.
Sure, no worries. Okay, that's that. And yeah, so definitely know these values. If x bar is not given to you, like this problem, for x bar it's easy, add them, divide them by the number of samples. But for most of the problems we had, and for the exam also, I believe it's just very time consuming to calculate everything for the sample standard deviation or variance, or sample average or standard deviation will probably be given to you, but I don't guarantee anything. So make sure you guys know the formulas and everything.